Good morning. We are going to discuss now on the ground resonance for helicopters. If you remember, we divided the dynamic instabilities of a helicopter in instabilities where the vibratory energy was derived from rotor rotation and where the vibratory energy was derived from the airflow. In which case, in the case when the energy is derived from the airflow, we discussed on the flutter. Today we are going to concentrate on a very typical helicopter instability, which is due to the coupling of two degrees of freedom and where the vibratory energy is derived from rotor rotation. Namely, we will discuss on ground resonance. To understand the ground resonance, one needs to recall the Coriolis effect. If you remember, the Coriolis effect is the apparent deflection of a moving object from a straight line when we are in a rotating frame of reference, in a non-inertial system of reference. As the video showed, the motion of the ball is seen in a different way by an observer placed in an inertial reference and of an observer placed in a non-inertial reference. We need to include the Coriolis effect when we are in a non-inertial system of reference. In our helicopter, we can say that exactly like an ice skater, where you can also see the Coriolis effect and the conservation of the angular momentum, because the blades are flapping up and down, it means that the center of mass of the blade will move back and forth in the plane of rotation. So it means that the blades are lead lagging or the blades are hunting. This is why, in order to avoid the hunting of the blades, so the motion of the in-plane of the rotor, we need to introduce a lead lag hinge. So, because the blades are flapping up and down, the center of mass moves towards and outwards of the axis of rotation, and as we have the conservation of the impulse momentum, we need to um, to add the lead lag hinge or the drag hinge. Here you see the lead lag hinge and you see also a damper. I will explain you why we need this damper. The ground resonance, it is an aeroelastic instability characteristic to helicopter, which is a combination between the blade lead lag motion and the airframe landing gear when the aircraft is not airborne. Usually it happens in the so-called soft in-plane helicopters. A soft in-plane helicopter, I recall you, it involves that the lead lag frequency is smaller than the RPM of the rotor. You have as a trigger a gust or a wind or a sudden control motion, a hard landing that it will displace the blades. In flight, each blade will leg and lead in such a way as to spiral the rotor CG towards the shaft. The problem of this instability is not due to the aerodynamic forces, but it's a pure resonance between the two modes, as I said, the lead leg of the blade and the landing gear. So, how important is the Coriolis effect for helicopter? It means that it is very important as it results in an instability. Such instability were happening in the early helicopters. There have been many accidents due to the ground resonance, and the resonance, then the instability explodes in a few seconds. It is characteristic to the old helicopters. I have a video, and to the newer helicopter. For example, you see a CH-47 tied down for safety, where the ground resonance is also happening. How to avoid ground resonance? We have to provide damping in both rotor and fuselage. Otherwise, we have to change the design of the rotor and to transform the blade from a soft in plane blade into a stiff in plane blade. Or we have to raise the fuselage landing gear natural frequency above the rotor operating RPM. For example, here you see the Me-70, the soft in-plane rotor classic to an articulated helicopter, and you see that there is a need for a hydraulic damper which is added to the lead lag hinge, which is here the lead lag, the drag hinge, in order to avoid the ground resonance. You see also the pendulum absorbers. Here you see an elastomeric lead lag damper that is added to the drag hinge. So you have the upper surface which is fixed to the hub and a lower surface which lead lags with the blade motion. Another example is, for example, in the CH-47 where they used wheeled landing gear in order to raise the fuselage, the landing gear natural frequency above the rotor RPM. Multi-blade stiff in-plane rotors. So going to the stiff in-plane rotors, it means, so going to hingeless helicopters it means that the ground resonance is not a problem. However, in this kind of rotors, it is possible that the so-called air resonance is appearing, and the air resonance is a kind of ground resonance happening in an airborne mode where the flapping motion of the helicopter is involved, and it is a quite destructive instability, difficult to predict. The Eurocopter, you see that they used a stiff landing gear also to avoid the ground resonance. In this way, I ended the ground resonance phenomena. There are many instabilities in a helicopters, and this is just ground resonance is just an example of the problems that we have.